Hello everyone, I'm Rahul Radhakrishnan and I will be presenting my course project for the course Pattern Recognition and Intelligence Systems offered at the University of Florida under the guidance of Dr. Dapeng Oliver Wu. For the project, I have implemented a synthetic aging model using conditional GANs with identity preservation. To get started off, let us understand the functioning of a generative adversarial network. Generative adversarial networks, otherwise known as GANs, consist of two neural networks, namely a generator and a discriminator. The generator network is responsible to reproduce the input distribution, whereas the discriminator distinguishes between the original image and the reproduced image. The framework of a GAN resembles a min-max two-player game because the generator minimizes the objective, whereas the discriminator maximizes the objective. In training the GAN, the networks are trained individually in alternating periods. This is because otherwise the generator is trying to hit a moving target and hence would never converge. Now, let us try to understand an alternate version of a GAN known as the conditional GANs. In a conditional GAN, the generator network and the discriminator network are conditional over some prior information. These prior information is incorporated in the reproduced distribution by the generator. The discriminator distinguishes between the two images with consideration of the prior informations provided. The training of a conditional GAN is similar to that of a GAN where the generator is trying to maximize the probability that the discriminator makes a mistake. Now let us try to understand the objective of the project. Synthetic aging. Synthetic aging or age synthesis is the process of transforming a facial image of a person at a particular age to the desired target age. Synthetic aging is currently a hot topic in the research field because of its wide range of applications in different industries. Synthetic aging finds its applications in industries like forensic art, entertainment, and cosmetology. It can find its application in restorative medical procedure to furnish the specialist with reference to disclose to their clients about the revived face beforehand. Now, let us discuss a few state-of-the-art face aging methods. Traditionally, two commonly used strategies for synthetic aging are prototype-based approach and a physical model-based approach. In physical model-based methodology, significance is given to the physical highlights of the face such as the skin texture and facial muscles. This model fails because it requires a huge amount of data and a large computational force. The prototype-based procedure consists of averaging the faces in a target group and incorporating the mature design in the integrated picture of the target age. This method fails because the identity of a person is lost when the aging pattern of an averaged face is incorporated. A conditional GAN with latent vector optimization for identity preservation was proposed in the paper titled Face Aging Using Conditional Generative Adversarial Network. The above proposed method failed because it calculates a latent vector for each image and hence requires a huge computational force. Also, the results produced by uh, this method, though provides identity preservation, does not give promising results for face aging. Now, let us understand the framework for the identity preserved conditional generative adversarial network. The framework of an IPC GAN consists of three modules: a conditional GAN for face generation, identity preservation module, and an age classification module. A conditional GAN is used for face generation to incorporate aging in the synthesized image. An alternate version of a CGAN known as the conditional least square generative adversarial network is used because the optimization of the object of CGAN is unstable and hence will result in poor results. The least square generative adversarial network enforces both the image towards the decision boundary and hence ensures promising results. To preserve the identity of the individual, in the synthesized image, a perceptual loss is introduced in the objective. Features extracted in a layer of the pre-trained network is used for identity preservation. For this purpose, a AlexNet pre-trained with ImageNet is swept through all the layers, and it was observed that convolution layer 5 produced the best results for identity preservation. For age classification module, I have used a pre-trained model during the training of IPC GAN. A small penalty is given if the synthesized image is correctly classified, otherwise a huge penalty is given. The dataset used for this project is a cross-age celebrity dataset. It consists of more than 1,60,000 face images of 2,000 celebrities from age ranging from 16 to 60 plus. The dataset is divided into 5 different groups depending on what age the face image belongs to. Group 1 10 to 19, Group 2 20 to 29, Group 3 30 to 39, Group 4 40 to 49, and Group 5 50 plus. The data set is pre-processed to remove and mask unreliable data and center crop and resize the image to 400 by 400. The data set is then split as 90% training data and 10% test data. I will be evaluating my model in comparison with a cycle GAN with latent or vector optimization for identity preservation. For this purpose, I have chosen 5 images, each from 5 different age groups, and each of these aged to different target age groups using both the models. I will try to show the aging from a younger person to an older person and also from an older person to a younger person in this manner. The results are present in the next slide, and it can be observed that the latent vector optimized cycle GAN does not show any vivid changes in the different age groups, and the generated images are blurry and unaesthetic. Whereas the results produced using the IPC GAN can be observed to have the same identity in all age groups, and face aging pattern in each of the age groups are evident. The results have been shown here. It can be observed that in the first row, the results produced using an IPC GAN shows clear face aging and also identity preservation. Whereas the results produced using a cycle GAN with latent vector optimization does not show any promising results, and the pictures are blurry and does not show any aging pattern. Now, I would like to demonstrate the testing of my model with one image and would like to demonstrate the face age pattern in each of these images. This image represents the input image in the age range 20 to 29 years. This image represents the aging pattern for the age group 10 to 19 years. This image now represents the aging pattern for the age group 30 to 39. This image represents the aging pattern for the age group 40 to 49. And this aging pattern resembles the 50 plus year age group. It can be seen that we can see vivid age pattern changes in from each group to another. Now, in conclusion, The generative adversarial network has shown immense results in image generation. The identity preservation module ensures that the synthesized image using a IPC GAN have all the high-level features of the input image, and the age classifier network guarantees that the synthesized image is enforced in the correct target group and hence makes aging pattern evident. This results in the IPC GAN producing promising results for synthetic aging. Thank you. And I will be posting a link to my GitHub with the code and all the network architectures and a paper related to this project. Please take a look at it and give me your valuable